Great. So now we're going to move on to the lecture challenge. Again, we will be listening to a lecture and answering a couple questions. So yeah, uh, let's see how this goes.
One of the things that inspires me the most about Mind's research is that it's grounded in physical reality, and yet it has the ability to go into the sort of farthest reaches of people's technological imagination. So we talk about quantum, we talk about machine learning. Because we have this commitment to solving real problems, I feel like our history and our connection to sort of earth, energy, and environment really allows some pretty exciting connections between where your feet are on the ground to, where your imagination can take you as far out into the future as you can possibly see. My name's Stephanie Tompkins, and I am the Vice President for Research and Technology Transfer.
You're listening to The Conveyor, the podcast that brings you the latest research, new discoveries, and world-changing ideas from Colorado School of Mines. Stephanie, thank you so much for joining us on our first teaser episode to discuss research at Mines.
It's a pretty exciting topic. There's so much going on, I'm not entirely sure where to start.
Well, I guess a good start is you are the Vice President of Research and Technology Transfer. Can you elaborate a little bit more about the research part as well as the technology transfer part?
Sure. Well, part of the university's mission is to advance knowledge for the betterment of society and industry. And it is a pretty active part of the university campus that people might not always see. It involves large numbers of our faculty members and I think a pretty significant portion of our graduate student population. And they're working across fields as diverse as planetary resources, water remediation, quantum engineering, and metallurgical materials engineering, manufacturing. The list could clearly go on and on. It's although it's all tied together, I think around some pretty exciting themes, which we can get to later. And the technology transfer part is what you do with the results of your research in order to actually get it out into society. So it's one thing to make discoveries and to invent new things. If they simply sit fallow, then you've sort of wasted your time. And so, technology is often transitioned through traditional academic means like publishing papers, which is great because lots of people can read those papers. But sometimes if you really want something to make it out into the world, it's going to need additional investment. It's going to need people who really want to champion the technology. And they're more likely to do that if they have maybe exclusive access to it or some kind of special privileges that allow them to be incentivized to make those investments.
Well, as Vice President, what makes research at Mines unique?
Our motto is Earth, Energy, and Environment. And when I think about how I might map out research, those are big problem areas, and they're pretty loose and open-ended problem areas. But along with that, we have extensive expertise in areas like material science and manufacturing. I think of that almost as like a foundation under the other three because you need that kind of capability in order to solve problems in earth, energy, and environment. And similarly, we have a really diverse array of expertise in what I think of as connectors and enablers of, in different types of technology. So an example might be mathematics and statistics, or machine learning and artificial intelligence, synthetic biology, or any type of biology as it might be applied to solving these kinds of problems. And when I mention quantum, that's another great example where the long-term potential of quantum computing, for example, is going to be hugely important to solving some of the really complex problems associated with Earth, energy, and environment.
Yeah, that diversity is important. What else sets Mines apart?
One aspect of Mines that's extraordinary is that it always has this very use-inspired focus on research. So you can think about research as being purely exploratory. And, you can also think of it as a different aspect of research is where people are actually looking at solving a big problem, and they've particularly focused their research towards how to solve that problem. Sometimes it's still very basic scientific research, but they're doing it with an end goal in mind. And I think that is a philosophy that tends to permeate a lot of Mines research projects. And what tends to get Mines faculty really excited is because that they have the chance to see end results of the research that have real impact. So part of that is that we do an extraordinary amount of research with industry directly. And I think it's something like 20% of our total research sort of income is from industry, and which is a very, very high percentage. It might be one of the highest in the country. And it's often done through consortia, where collections of companies in a certain industrial area will form a consortium working with universities, and then they will pay through, for example, like membership fees or through sharing of data and results and things like that in order to advance the specific needs of the overall industry. And so, our Steel Center is a great example of that, which focuses on steel processing methods and has been around for almost 30 years, has a global membership base, and has inventions that are, at this point, embedded in steel processing plants pretty much as industry standards.
What a great opportunity for the students at Mines to really have that not just the hands-on, but just that networking opportunity on such a massive scale, a prestigious scale at that sense.
Exactly. The students get a lot of professional development help through this because, part of what they get to do is present the results to these industry members. And the industry members are pretty excited about it too, because it's a great opportunity in order to recruit some of those students and to build up their long-term workforce pipeline.
What do you see for the future of research at Mines, and how does the work researchers do at Mines remain relevant?
So in order to solve societal problems, you typically have to work outside just a single discipline, and you need to be able to collaborate with folks who work in different fields. That is really common already, but I think the future of research at Mines and really of research around the world is going to have to really require more and more of that multidisciplinary collaboration, sometimes at levels that are really, really intimately connected together. And we see that happening more and more as different aspects of Mines' expertise, expand in directions that may not have existed previously. So, the Space Resources Center, our Planetary Resources Center, is a great example. If you go to their website and you look at their membership, it spans, I think, close to a dozen different research departments, including our Policy Institute, as well as, say, chemistry and mining and metallurgy and electrical engineering. And you can kind of run down the list and you realize that all of those folks are coming together to think about what do resources in the future involve. And this isn't, I think when people think of space resources, they often think of people going maybe to an asteroid and mining metals out of it. That may be one aspect of space resources, but really think about a future in which we have a space-based economy that involves larger and larger orbits, going out as far as the moon in order to get raw materials, for example. And that economy is going to have to be powered by resources that come from.
Okay, so that was the podcast for Stephanie Tompkins, and the questions are, first question is, based on Stephanie's speech, machine learning is not something important for the Colorado School of Mines. It's a yes or no question. The second question is, Stephanie talked about the importance of research investment. Again, this is a yes or no question. And the third question is, what is the job position of Stephanie? So A, Vice President, B, President, C, Provost. So let's see what the audience thinks. And the results are in. So the first question, no wins by 74%. Second question, yes wins by 95%. I believe that's the highest we've gotten so far. And third question, A, Vice President, wins by 64%. Let's go to our instructors.
Yes, so I agree with all three answers. In the first question, she mentioned machine learning as an important topic for the university, and also the whole speech was about how important is research for university. And in the beginning of the audio, she mentioned that she's a vice president.
Yeah, I agree with the first question and basically all the questions. Machine learning is an important aspect in Colorado School of Mine. So the answer is no on the first one. Stephanie talked about the importance of research. That is correct. She spent a lot of time talking about that. And then number 3, she is the vice president.
Yep, I have to agree with the majority on all 3 questions. Machine learning is important in the Colorado School of Mines. She did talk about the importance of research investment, and she did mention that she was the vice president.
I totally agree with the majority of the answers of the audience. She mentioned that machine learning is important, and that she thought about the importance of research investment, and at the beginning of the video she mentioned that she's the vice president, so it was quite clear that the questions were obvious.
Yeah, I also do agree with our instructors and audience. First 2 questions are correct, and the third question is also correct, because she mentioned in the beginning that Stephanie was a vice president of research and technology transfer. So,
Yeah. This was actually like really interesting because we kind of have an expert with us today on machine learning. So, yeah. I guess we can move on to the next part, and yeah, let's listen to it.
What exactly is carbon capture? We asked John Bradford, geophysics professor and vice president for global initiatives at Colorado School of Mines, to explain.
Carbon capture is effectively preventing the carbon from getting into the atmosphere. So we're emitting it, and we're emitting it from all sorts of sources. Some of that might be a power plant that's burning gas or burning coal, could be a tailpipe emission. There's also a lot of CO2 emission that comes from concrete production. So that's another point source of emission. There's also CO2 emitted when you brew beer, for example. So there are a lot of different sources. So the carbon capture component is just capturing the CO2, preventing it from going into the atmosphere. And so there's a lot of technological development that has to happen for that to work. And, we know how to do this now. There are technologies for doing it, ranging from, specialized membranes that have special chemistry in them that capture the CO2 as the gas passes through the membrane. Of course, right, growing plants, that's a good way of capturing carbon as well. And so there's a lot of research going on into biocapture of carbon. So there are different ways to do it. The utilization part is then using that carbon in some other way that might be useful for society. There's certain processes for producing concrete that would use some of the carbon and then store it. There are processes for producing biofuels. So you can grow certain types of algae and convert the algae into a different type of fuel. When you use that fuel, then again, the CO2 is being emitted, so you have to capture it again, but you make a closed loop in that way rather than a one-way emission. But then we also know we have a lot of carbon it's just sitting out there in the atmosphere. We have too much in the atmosphere now, so we need to pull that out of the atmosphere. So there are large systems for passing the atmospheric gas through these big membranes to capture the CO2.
To learn more about how Mines is helping shape the world's energy future, visit mines.edu/energy future.
All right, so that was John Bradford, and the questions are, Dr. John failed to explain what is carbon capture. It's a yes or no question. 2, Mines do research on carbon capture. Again, this is a yes or no answer. And Mines in the podcast means Colorado School of Mines. Another yes or no question. So let's see what the audience thinks. And the results are in. So the first question, no, wins by 60%. The second question, yes, wins by 85%. And then the third question is kind of close, but no, wins by 53%. Let's see what the instructors think.
I see that I don't know, maybe Dr. John failed because he didn't talk that much he wasn't that inclusive, maybe. So I say yes for the first question, and for the second question, I go for no. And for the third, sorry, for the second question, yes. And for the third, no. That's what I think, maybe.
Yeah. One and two, I think would be correct, and then the third one would be, I'd agree with yes. So yeah.
I will say that Dr. John really explained how carbon capture is. That he said that it's basically preventing the carbon going to the atmosphere. For the second question, I would say yes. The university do research on carbon capture, and at the third question, I will say that MICE means the Colorado School of Mines. So I will say yes at the third question.
I think in the first question, I think like Meyer, because he didn't explain too much about carbon capture. He explained about carbon capture, CO2 emissions, and about biomass from algae. But I'm not sure if he explained too much. And the second question is definitely yes, and the third question is also definitely yes, because the person who was talking, who was explaining about carbon capture, he was a vice president of Colorado School of Mines. He was in geophysics or something like that. So.
Yes, so for me, I think for question one, I would have answered no. I think he didn't explain in a lot of detail, but he did give some different methods of carbon capture that he did mention. So I think he explained a little bit on that. And question two is definitely yes, the school does research on carbon capture. And question three, the answer should have been yes there as well. I'm not sure if they mentioned it very much in this section, but in the previous lecture we heard was also from the Colorado School of Mines. And so I think we could infer from both of those together that mines in this case does mean the school.
Yeah, I agree with Paul. The first question says Dr. John failed to explain. He might not have explained in detail, but I don't think he failed to explain the carbon capture. So that's a no. Mines do research on carbon capture. That's a definite yes. And number three, mines in the podcast means Colorado School of Mine. That is correct. So that would be a yes.
Yeah, I would say that his whole conversation was about the carbon capture. So no, he didn't fail to explain like what is carbon capture. So I will go for no for the first one, and the second one is yes as the majority, and the last one I would go for yes.
I see. These questions kind of caused some controversy because we had a little bit of disagreement in the beginning with the instructors. So this is interesting to hear.